The concept of an interplanetary internet is crucial in the context of supporting space colonization. As humanity moves towards establishing settlements on the Moon, Mars, and potentially beyond, the need for robust and reliable communication systems becomes a priority. Such systems would not only enable communication between Earth and its colonies but also among the colonies themselves. The interplanetary internet would extend the terrestrial internet into outer space, ensuring effective control of spaceborne and planetary missions, enhancing scientific data return, and enabling astronaut communication. Challenges in establishing interplanetary internet. The primary challenges of establishing an interplanetary internet stem from the vast distances involved, which introduce significant delays, latency, and require high degrees of signal integrity and network reliability. For instance, at its closest, Mars is approximately 3 minutes away at the speed of light, and at its farthest, the delay is about 22 minutes. This means that traditional Earth-based communication protocols like TCP/IP are inefficient for such environments due to their assumptions about packet loss being a rarity and their reliance on relatively low latency links for efficient data throughput. Delay Tolerant Networking, DTN. One of the most promising solutions to the latency and disconnection issues is Delay Tolerant Networking, DTN. DTN is designed to handle long delays and intermittent communications, characteristics expected in the space environment. Instead of assuming a continuous end-to-end connection, DTN uses a store and forward technique where data packets are forwarded from one node to another, stored temporarily, and then sent to the next node, effectively hopping towards the destination. This protocol is robust against disruptions and disconnections, which are likely in interplanetary space due to planetary alignments, solar interference, or equipment malfunctions. Network architecture and infrastructure. The architecture of an interplanetary internet would likely be hierarchical, involving Earth-based internet, satellites in Earth orbit, deep space communication networks, and local networks on other planets or moons. Satellites and space stations could act as nodes and data relays, supporting both human and robotic missions. High-gain antenna arrays, laser communication technology, and other advanced telecommunications equipment would be necessary to handle the bandwidth requirements and to boost the signals across interplanetary distances. Applications and implications. The applications of an interplanetary internet are vast. For scientific missions, it could allow for more timely data transmission back to Earth, as well as enhanced control of remote instruments and rovers on planetary surfaces. For human colonies, it would be critical for Earth independence in daily operations, emergency responses, and personal communications, helping to alleviate feelings of isolation among colonists. In terms of governance, an interplanetary internet raises questions about the management of space-based communication assets, internet neutrality in space, and the protection of privacy and data. As different nations and private entities may establish their own nodes and infrastructure, international agreements and regulations will be critical to ensure that the management of the interplanetary internet is fair and equitable. Future prospects. Looking forward, the development of an interplanetary internet will likely be incremental. Initial steps might focus on enhancing communication between Earth and the Moon, as countries and private companies aim for lunar exploration and settlement. Lessons learned from these missions could inform the development of similar infrastructure for Mars and other destinations. Furthermore, as space traffic increases, there is a potential for commercial opportunities related to data relay services, network management, and cybersecurity in space. The growth of an interplanetary internet could also drive advancements in quantum communication and computing, providing ultra-secure and high-capacity links needed for operations across space. In conclusion, the development of an interplanetary internet is not just a technical challenge but also a necessary evolution to support the future of human space exploration and colonization. By enabling reliable communication and data sharing across vast distances, it will play a pivotal role in extending human presence in the solar system, offering a digital backbone that supports a wide range of activities from scientific research to daily life in space communities.